is just one of the ways that optimal stopping rears its head in daily life. Committing to or foregoing a succession of options is a structure that appears in life again and again, in slightly different incarnations. How many times to circle the block before pulling into a parking space? How far to push your luck with a risky business venture before cashing out? How long to hold out for a better offer on that house or car? The same challenge also appears in an even more fraught setting: dating. Optimal stopping is the science of serial monogamy. Simple algorithms offer solutions not only to an apartment hunt, but to all such situations in life where we confront the question of optimal stopping. People grapple with these issues every day, although surely poets have spilled more ink on the tribulations of courtship than of parking, and they do so with, in some cases, considerable anguish. But the anguish is unnecessary. Mathematically, at least, these are solved problems. Every harried renter, driver, and suitor you see around as you go through a typical week is essentially reinventing the wheel. They don't need a therapist. They need an algorithm. The therapist tells them to find the right, comfortable balance between impulsivity and overthinking. The algorithm tells them the balance is 37%. There is a particular set of problems that all people face. Problems that are a direct result of the fact that our lives are carried out in finite space and time. What should we do and leave undone in a day or in a decade? What degree of mess should we embrace? And how much order is excessive? What balance between new experiences and favored ones makes for the most fulfilling life? These might seem like problems unique to humans. They're not. For more than half a century, computer scientists have been grappling with, and in many cases solving, the equivalence of these everyday dilemmas. How should a processor allocate its attention to perform all that the user asks of it, with the minimum overhead and in the least amount of time? When should it switch between different tasks, and how many tasks should it take on in the first place? What is the best way for it to use its limited memory resources? Should it collect more data or take an action based on the data it already has? Seizing the day might be a challenge for humans, but computers all around us are seizing milliseconds with ease, and there's much we can learn from how they do it. Talking about algorithms for human lives might seem like an odd juxtaposition. For many people, the word algorithm evokes the arcane and inscrutable machinations of big data, big government, and big business, increasingly part of the infrastructure of the modern world, but hardly a source of practical wisdom or guidance for human affairs. But an algorithm is just a finite sequence of steps used to solve a problem, and algorithms are much broader and older by far than the computer. Long before algorithms were ever used by machines, they were used by people. The word algorithm comes from the name of Persian mathematician al-Khwarizmi, author of a 9th century book of techniques for doing mathematics by hand. His book was called Al-Jabr wal-Muqabala, and the al-Jabr of the title in turn provides the source of our word algebra. The earliest known mathematical algorithms, however, predate even al-Khwarizmi's work. A 4,000-year-old Sumerian clay tablet found near Baghdad describes a scheme for long division. But algorithms are not confined to mathematics alone. When you cook bread from a recipe, you're following an algorithm. When you knit a sweater from a pattern, you're following an algorithm. When you put a sharp edge on a piece of flint by executing a precise sequence of strikes with the end of an antler, a key step in making fine stone tools, you're following an algorithm. Algorithms have been a part of human technology ever since the Stone Age. In this book, we explore the idea of human algorithm design, searching for better solutions to the challenges people encounter every day. Applying the lens of computer